All right. Hey, gang. Sorry that I had so many technology difficulties this morning in class. I did want to go back over and just give you a couple of the quick and dirty tips on putting your data together in Excel. I always recommend, if you can, when you're using Excel for data collection, that you have only one data point in each cell so that it's easier to manipulate and to report, even if you're doing descriptive statistics, where you're not actually analyzing anything, you're just reporting out. So each column should be a variable. So like the variable here was, do you like the essentials of research class? Age, height, these are your variables here. Each line or row should represent one case. So that would be one individual student responding that, no, they don't like the class, they're 23 years old, 65 inches, etc. Now, a couple things that you can do right out of the gate to make life a little bit easier. One is that you can highlight the variables that you want to look at or manipulate. And you can go up to your little data tab here, click on that, and you can click filter. And that filter will allow you to click a down arrow, and then you can see, like if you want to, that's a bad example. Let's choose a nominal data set like sex, and you can toggle on and off what you want to look at from there. And it just makes things a little bit easier. If you have not yet learned how to do a pivot table in Excel, I highly recommend watching a brief YouTube video on how to do that. It'll be very beneficial for you. But like I said, try to keep all your data, if you can, in one worksheet and one little data point per cell. So a couple things that you can do when you are looking at how you would like to report out some of this data. For instance, let's say that I want to know how many responses there are. I can quickly go down and look to see that I've got column A79 through column A2. So if I wanted to count, I mean, I know it's easy to do the subtraction, but you can do a count function, click on that, and then I can say A2 colon A79, close your function command and click enter, and that's 78. Okay, so if we wanted to start kind of putting things together here, let's move that over a little bit. And this will be total subjects. Okay, and then let's say we want to know loves class, right? And then we can do a count if statement. So click equal count if. And then you'll notice it gives you the directions under here and then what the criteria are. So again, our data array or our range is going to be A2 colon A79. So that's, and you notice that my data over on the left highlights. Then it's asking for a comma, and then it wants your criteria. So that is what you're looking for. So we want who wrote that they love the class, that which we coded as a 1. Click that, put 1, close your function. So 30 of the 78 noted that they liked the class or loved the class. If we go to hates class, we can come over here. Now you could do the same thing. You could just subtract, obviously, 30 from 78 and get the number. But let's practice again. We're going to do equals count if. We're going to do the same thing, A2 through A79, comma. And now we're looking for people who said they don't like the class, or 2, end your function. That gives you 48. Now, again, I'm assuming that most people know how to do a lot of these functions on here. Now I'd like the percentage of this. So I'm going to say sum, and I'm going to look at 30 divided by 78. And I'm going to do equals sum and I'm going to say 48 divided by 78. And so there's our percentages of who loves the class versus who hates the class, right? Now I want to look at some of the information around our first continuous variable, which is age. And I would really like to know the mean and the standard deviation of that continuous variable. So I'll say mean age and come over here, and here you'll do your equal sign to notify Excel that you want to use one of its functions. And here we're going to look for the average. So we'll click average. And again, we know what our data stipulations are. So this is going to be B2 through B79 in your equation. And so the average or mean age is 27 years old of the quote unquote people who finished this survey. Now, standard deviation is meaningless unless you have, or your central tendency is meaningless unless you have some type of measure of the variance, the range. Here, when we're looking at mean within continuous data, we want standard deviation. So we'll abbreviate it with STD. And we're going to go equals and then ST. And as you see that, you'll notice ST deviation pops up as a function. We'll click that. It's same kind of deal where we're going to look at B2 through B79, close your function. So your standard deviation for this continuous data set is 2.5. So you would report this out that the mean age of the student was 27 years with a standard deviation at 2.5. Remember what I told you in class also, the trick is that if you want to know if your data is normally distributed, if it looks like a bell, you're looking to see is your standard deviation less than half of your mean. If it is, it's pretty good assumption that your data is normally distributed. So we can do this for a number of other things as well. We can do mean height. And let's do the same thing, equals, and we'll say average. Click on the function, and this is going to be C2 through C79. And so our average height is 68 inches. Don't forget about your standard deviation. And we're going to say, ST, go to your deviation. And we're looking at C2 through C79. And then there you have your standard deviation, 5.4 with a mean height of 69. We have a heart rate here, same thing. We can do mean heart rate, look at equals, average, and we can say average of E2 through E79. Oops, that would be bad, huh? Close it, and there's our average heart rate. And then don't forget about your standard deviation. And we say E2 through E79, and there's your standard deviation. Note it's a little bit bigger, but it's still less than half. So there you should be pretty good. Now, another trick when let's say you have a huge data set and it's just crazy big. One of the things that you can do instead of going through and scrolling, like let me show you a quick example. Here's a sample spreadsheet that has something like 30,000 lines of data in it. It's at 22,000. It would take forever to scroll through all of this. So what you can do is put your cursor on the very bottom last piece of data you have in this column, come up, and you'll notice that that is located right there in the top left. If you click on that and then move your arrow over and select A1 : enter, it will highlight the whole thing. And then you can copy that if you need to put that into a chart, data collection, whatever it might be. Okay. So I showed you how to do the mean and the standard deviation. So now we'd like to actually dive in and compare some things. So remember, if we look at this, whether you like the class, yes or no, is nominal data. Age is continuous. Height is continuous data. Sex is nominal. Heart rate is continuous. So let's say that we want to look at the difference potentially between those who like the class and those who do not like the class in terms of their mean heart rate. So we can look at this a number of different ways. One way that you can do it is that we can go up here and we can select only the people that like the class. So there you go, right? And then we can go down and we can say, and this only gives you a few of the things that you'd like. So we can say, let's do mean heart rate, mean heart rate. And then up here, we would say likes class, hates class. I mean, I don't know how else to say this, right? And get rid of that. And we're looking at the means, and then we want a p-value over here because we're going to compare the means of the heart rates between those who like the class and those who don't. So right now we only have likes the class selected in our filter. So I can come over here essentially and just highlight and come down here and look at my average. My average is 83, but I'd really like to do a little bit better job than that. So I'm going to say sum average, and I'm going to actually select my variables here, or my data. And notice we get a little bit tighter information. Now what we're going to do is I'm going to come back to your like class filter, uncheck 1, check 2, and then we'll be able to, where'd all that go? That moved it around on me, my apologies. Okay, I'm back. When you use these filter functions, it screws up the data when you try to use it within this. So let's not do that. Let's actually make this a little bit easier, and we'll sort the data using data and then your sort feature. And so now our data is nicely distributed here, either 1 for likes class, 2 doesn't like class. So I'm going to come back over here to our hates class, average. Okay, and then I'm going to come over here. So remember, 2 is doesn't like the class, 1 is does like the class. Okay, so I'm going to come over, and this is our heart rate variable, and I'm just going to select this as our data array. Okay, so those are highlighted. I come back up here, close my statement. And so if you notice here, the average heart rate of students who liked the class was just slightly higher than the average heart rate of those who don't like the class. But what we really want to know is there a difference statistically? And so we are going to actually do a student's t-test. So this is independent. So we're going to go equals t, and that brings up test. And let me show you one other way to do this too. If you're in the cell where you want it to go, now why does this keep changing? That's very odd. I am not sure why it keeps changing on me whenever I do something. But either way, I'm sure it has something to do with the way I've got the spreadsheet set up. But anyway, what you can do is you can go up here to this FX button and click that, and it will give you a whole list of all the different things that you can use and an explanation of what it actually means and how to set it up. So there's another nice way to do that. So I'm going to do a student's t-test. And that first it asks, you'll notice down here, for my first array of data. Well, I want to look at the heart rate for only those who like the class in array 1. So I'm going to go here, scroll up and highlight. Okay, and then that's my amount of data. Now from here, what it wants is it wants me to put a comma, and you'll notice now it highlights array 2. So now it wants my second set of data. So here, if you scroll over, this is where 2 begins. Those are the people that don't like the class. So I'm going to highlight that, drag down, and you can use the the cell naming functions as well if you don't want to mess with it this way. Scroll back up to your function. It should pop back up. And then you put another comma on, and now it's going to ask you, do you want a one-tailed or two-tailed t-test? Well, depending on what you want, remember one tail is it less than or is it equal? The two-tailed can either tell you less than, equal, or greater than, right? So it measures both sides of the bell shape. Let's just do a one tail, and then I'm going to do comma. And now it wants to know, is this paired or are these equal variances assumed not paired? And I'm going to say two sample equal variance assumed, close my argument or my function and click enter. And there's my p-value. Okay, so I don't know why the means are changing. I'm doing something goofy in here, but that's how you do it. And this is the p-value you would report. So your mean heart rate is 85.6 here, 84.6 here, with a p-value of 0.37, which is not less than or equal to 0.05. So this is a non-statistically significant difference. Now, the next thing I'd like to show you, I'm just going to delete this real quick. And the next thing is chi-square. So if you wanted to compare nominal data, let's say that we wanted to see, is there a difference between those who like the class or dislike the class and their reported sex? That would be, both are considered nominal data. So this would be a chi-square analysis. Now you could do the frequencies, right? Because you would say, you would set up like a 2 by 2. So you could say class, what's the word class perspective, how's that? And you would say likes, dislikes, and then up here you could say male, female. Okay. And then what you would wind up doing is you would do your count, equal count, and you'd put your counts in for each of these things. And then you could actually do a chi-square. Now, I am, just for the sake of time, since I already showed you how to do this, you come and hit equals, chi-square. And here's your chi-square test. And now it'll ask you for your range. Okay, so we're going to do here. Okay, and then go back up. Where'd it go? Then we're going to do comma, and now it's going to do expected. Okay, come back up. Close it, and this should give you the p-value of your chi-square test. Obviously not great. So there was no difference when you come down and look at it. So these are just some of the basics. Now, a couple others that I thought were important. Somebody asked me, well, what if I want to look at, say, age versus height, and those are two continuous variables. We can't really compare them. Is one higher than the other or what have you, but we can run correlations on them. So we can actually see, how are they related? Is there a linear relationship? And so you can actually do a correlation. So it asks for array 1, and I'll highlight those. Okay, and then as we come back up, it's going to ask for a comma, and now it wants array 2, and I'm just going to say C2 through C79, close it, and then that is actually the The correlation coefficient, not very strong, not very good, but there is a somewhat negative linear relationship between the age and the height. So this is how you do some of these real basic standard things in Excel. I recommend going a little bit deeper in if you can. The other thing is, if you're concerned and you're not really sure how to do some of these things, like how to work with some of these data sets, don't forget that you can change different data types around. It's always very easy to go from continuous data to either ordinal or nominal data. So for instance, you could change the age. Remember, our mean age, I think, was like 26. You could create a different variable that says everybody over 26 versus everybody under 26. So you'd have two, like, yes or no nominal type data points in that nominal variable. You can do the same thing with heart rate. You could come up with multiple different ones. You could say heart rate of 50 to 70, 70 to 90, 90 to 110. You catch my drift. You could even turn it into some type, and that would also be considered some type of ordinal data if you had multiple and there was some order to it. So all of these things can be done in order to come up with some basic ways to look at the different types of data that you have. You can also create bins as well. And this is a little bit more complicated, but you can do count if statements, and then actually, let's say that I wanted to know how many in this group were 0 to 50 inches, 51 to 60 inches, etc. You can actually spell out what you want your bins to be. You could say 50, 70, 90, oops, something along those lines, right? And then as you do that, as you do this 50, 70, 90 situation, it'll ask you when you go in to do your like frequency statements, you know, where your bins are at and what the definitions are. And then that will create almost like a little table for you of your frequencies of all of those different ranges of information. So I hope this was helpful. If you need any other help or have any questions, feel free to drop me a note. Don't forget that not every research study has to have analysis. It can have just descriptive results where you're just presenting the frequencies of what you found. But if you do want to compare differences between variables or between data sets, then some of those things in the table that I showed you this morning are reasonable to do. And Excel can do most of what you saw. You just need to go up here and you have to find it. Okay, thanks, good luck, and have a great rest of your week.